Hello guys, happy to have you on my weekly physics challenge. This is day one of the challenge. Now today I am starting with equation of motion. So today I will just give a brief explanation of the equation of motion with all the equations and what we need to note when using the equation, right? Good. So what is the idea behind an equation of motion? An equation of motion, these are equations that we use to calculate the motion of an object in a straight line with uniform acceleration. When an object is moving in a straight line with uniform acceleration, what we are going to consider is the distance the object is going to cover because it's in motion, right? So we have our distance. The distance, we use S to represent the distance the object will cover, right? We have the time t the object is going to cover, and we have said that the object move in what? In a uniform acceleration. That means we have the acceleration, right? We have acceleration, which we use small letter a to represent it, right? Good. Now this object that is moving with uniform acceleration, it has a change in velocity, right, which is our acceleration. So we have what we, for the first equation, we are going to have this. Considering an object moving with uniform acceleration, right, that means we are going to have acceleration is equal to change in velocity over time, right? Now change in velocity is expressed as what? Final velocity minus initial velocity all over this, right? All over my time. So what I have is this is equal to v minus u t, right? Good. Now if I cross multiply this, what I'm going to have is at equal to v minus u, right? Make v the subject formula, which is the final velocity. That means I'm going to carry u to this side, which will turn to a plus sign. So rearranging, I'm going to have u plus at equal to v. Therefore my final velocity is equal to u plus at. This is the first equation of motion. This is the first equation of motion. Now this equation is used to find velocity when initial velocity is given. This is the final velocity I mean. When initial velocity is given, when acceleration is given, and time is given, you would use this to find your final velocity, right? Now let's consider equation 2. So to get our second equation of motion, we are going to consider the average velocities, right? Now we have our average velocity is equal to what? The two velocity. When we're talking about average, is the summation of the quantities divided by the number. So I have two velocities, which is v plus u, right, equal to 2. This is average velocity, right? Now recall from equation 1. Recall from equation 1. This is our equation 1, right? That v is equal to u plus at, right? So wherever I have v, I'm going to replace it with u plus at. So what I'm going to have is my average velocity is equal to u plus at plus u divide everything by 2, right? Good. I will rearrange u plus u will give me my average velocity is equal to u plus at divide by 2. My average velocity is 2u plus at, right, divided by 2. I can simplify this like this. This is 2u divided by 2 plus at divided by 2, right? Good. So this will cancel this. My average velocity is equal to what? U plus at over 2, right? Good. Now we are going to consider the distance of this object. And what is the principle of distance? Distance is equal to what? Velocity times time, right? Good. So that means distance s is going to be, distance is equal to my average velocity times time. What is my average velocity? This is my average velocity, right, which is u plus at over 2 times time, right? I will use this t now to open this bracket. So distance is equal to this t times u. I have this plus at squared over 2, right? This is my second equation of motion, right? Now in this equation of motion, look at what we have. We have distance, we have initial velocity, we have time, we have acceleration, we have, yes, time divided by 2. So whenever you're asked to calculate distance and the final velocity is not given, which is v, this is the equation you would use. Very simple, right? So now let's see how we get our third equation of motion. Let's go there. Now to find the third equation of motion, what we are going to do is that we are going to use equation 1, right? My equation 1 is v equal to u plus at, right? What we do is when we square both sides of the equation, square this side, which I have v squared equal to u plus at squared, right? Now I will simplify this side, which I'm going to have is u plus at, the same thing, u plus at, right? Let me open the bracket. U times u, I'm going to have u squared plus u times at, I will have u at times u plus this plus at times u, I'm going to have u at times at plus a square t square, right? Good. Let me simplify it the more. What is common? I have u square here plus this is uat plus uat is equal to 2uat plus a square t square. Good. Now what we are going to apply here, we are going to apply factorization, right? That is, what is common here and here. That is what we are going to do. Alright guys, how far are you enjoying this challenge? Okay, please, I will need a like, a comment on how far you're following this challenge based on the one before we proceed to the final two equations. Don't forget to subscribe, like the video, invite family and friends to join the challenge. Thank you. Let's proceed. Consider this side and this side, right? You notice that I have a is common to both sides, right? I can factor a out and at the same time factor 2 out, then introduce a division of 2 here. This is just a simple mathematics principle. What I just said is that, let me bring this one down, u squared plus 2a open bracket 2a come outside. What do I have remaining here? I have ut plus 1a is going to remain here, right? I have a will remain, then my t square, right, divide by 2. If I multiply or open this bracket, I'm going to get back to this aspect of it, right? Good. Now, let's continue. U square plus 2a. Now, recall, this is ut plus at square divided by 2. Is this thing familiar to you? Yes, familiar, because this is equation 2. It's still here. Look at it here. Ut plus at squared divided by 2. This is our equation 2. What that simply means is that ut plus at squared divided by 2 is my distance. So very simple. I'm going to replace everything here with my distance s. So everything here we have been doing v square, v square, v square, v square, v square. That means v square is equal to u square plus 2as, which is my distance. This is equation 3, right? This is our equation 3, right? Very simple. Now let's get the final equation. Stay with me, please. So to get our third equation is very simple. Is distance is equal to our average velocity times time. So what I have, this plus this divided by this times time, right? This is our fourth equation of motion, right? These are the equations we use when considering an object moving in a straight line, that is linear motion.